Hello. So in this video, I'm going to discuss assignment number 6. Okay. So let's get started. Okay. So first, the question is, in the first question, we have to find a root for this polynomial. Okay. Not find a root. I think it's asked us to show that we have a root in interval -1 to 1. We just have to show there exists a root. Okay, we do not need to explicitly show that this is the root. Just we have to show there exists some root. Okay. Okay, so the way we are going to do that is that we are going to use Rolle's theorem. Okay, so you know Rolle's theorem. So if f ab to r and f is differentiable, and then differentiable in this, and f is continuous in whole AB, FA is equal to FB, then there exists C such that f dash of C is equal to 0. Okay, so I'm going to take this capital F of x is equal to, let's say, x6 plus x cube plus x square minus x. Okay, capital of x. Okay, so if you differentiate this, you will see this is equal to, let's denote this by f, capital F. Okay, this is also capital F. Okay, so okay, so f dash x is, you calculate this, you will get 6x5 plus 3x square plus 2x minus 1. Okay, you check this. Okay, so and also this one is differentiable in -1 to 1. Okay, and it is also continuous because this is polynomials. Okay, polynomials are continuous, and it is also differentiable, so we can use Rolle's theorem here, and you check that f minus 1 is equal to what, and f minus 1 is, you calculate this one. Okay, so you will get what, 1 minus 1 plus 1 plus 1, so you will get 2, and you calculate f of 1. F of 1 is you put 1 here, 1 to the power 6 plus 1 to the power u plus 1 to the power square minus 1. So you will get 1. 1 plus 1, 2. Okay. So f minus 1 is equal to f1. Then, so we have verified this, right? Differentiable also it is true, continuous also it is true, and fa is equal to fb. So that means f dash has root c in -1 to 1. Okay. And this c I forgot to write a comma b, and f dash is this one, right? So 6x square 5 plus 3x square 2x minus 1 has a root in -1 to 1. Okay. Okay. Let's go to question number 2. Okay. So this question asks us to show that f of x is equal to x 3x plus x cube. This function domain we are given is all of R, has no extremum points. Okay. So let's assume for the sake. Okay. Let's assume for the sake of contradiction that fx has a extremum point. Okay. Now you know if the way I'm going to do is if certain function has a extremum point, f let's say a to r has a extremum point, then and f is differentiable. A is an let me pause for a while. Hello. Okay. So if your function f, which is defined from a to r, a is your domain, has a extremum point, and f is differentiable on all of a. Okay, and a is an interval. Okay, and interval is something like this. Okay. Or a can be something like a infinity minus infinity to a, or a can be something like this. Okay, a is a number. Okay, small a is a number. But you cannot take a to be something like this. Okay. You cannot take no. You can, if you want to take this type of things, then you cannot apply at endpoint. A, B not included. Okay. Okay. Then only you can apply the theorem. I will shortly give an example why you cannot take A and B, why you have to exclude A and B. Okay. Okay. Okay, I didn't write the full theorem. Okay, let's say C, then f dash C is equal to 0. Okay, so using this theorem, what does it say? That f dash of C is equal to 0. Okay, so if f dash of C is equal to 0, then what do you do? What is f dash C? Our fx is 3x plus x cube. F dash of x is equal to 3 plus 3x square. Okay, so this one will be 3 plus 3 square 0. Okay, so 3 is this possible? 3 plus 3 c square is equal to 0. This is not possible, right? Because c square is greater than equal to 0 always. Okay, and so 3c square is greater than 0, and 3 plus 3c square is equal to greater than 3. So you cannot have equal to 0. Okay, at least for real numbers. Okay, so there is no such c. Okay, so that is your contradiction, because we said we have such a c. Okay, such an echelon point. Okay, so uh, okay, so I was going to mention why you cannot take the endpoints. Okay, let's see an example. Okay, just take this example. Fx is equal to x. Okay, and this is 0 to 1. Okay, and 0 to 1 means f is from 0 to 1 to r. Okay, this is your domain. Let's see. F dash x. What is this? This is 1, right? Okay, so you can see this has a extremum here, 0, right? And it also has an extremum here. F has an extremum at 0. In particular, it has a minima here and it has a maxima here, right? Okay, so let's see, does f dash of 0 is equal to 0? No, right? F dash of 1 is equal to 0? No, right? So this theorem fails when you includes the endpoint. Okay, so take that thing into account. Okay.